Hi, welcome to the second part of my video. I was talking about uh, pooling substation, uh, what is PSS, what is pooling substation, and what are the main parts of it, what are the bays. I was touching upon the 33 kV side. So now I will talk about the number of bays which are there in a common substation. Firstly, there is a incomer bay, and then there is a transformer bay in which the transformer is there. If there are two transformers in the substation, then there would be two transformers, uh, transformer 1 bay, transformer 2 bay. Then there is also a bus coupler bay. Bus coupler bay is used in a substation uh, in the time of the outages. In operation and maintenance, it is used it is very useful in the operation and maintenance time, the bus coupler bay. And then there is a line bay, and from that line bay it is connected to our the dead end tower. Then that dead end tower goes into the transmission line, and that transmission line goes to the power grid substation. Now I will talk about in depth. In depth, I will talk about the substation and what in substation in what is there. So, in the substation, I will firstly talk about the various equipments which are there. Firstly, in the substation, one of the most important equipment is the lightning and the surging arrestor. The lightning and the surging arrestor in the 220 kV side, these are erected in the first most part of the line bay. It is the most outermost equipment. Uh, this equipment, the lighting and the surge arrestor, both are the same, one and the same name. So we will say them as LA also, and we can also say them as SA also, which is the surge arrestor. Lighting arrestor, it captures the light if there is any lightning flash over voltage from the above the sky, or in the line. It can directly go to the ground, that surge, that lightning. And the lightning and the surge arrestor, they are also used. It is mandatorily used in our power transformer, uh, in HVN and the LV side, both side it is used. And in this surge arrestor, we also have the surge monitor interface, uh, which measures how much surges it has encountered. So it is there are many points in the surge arrestor if you want to see. Uh, According to the various voltage levels, different types of surge arresters are selected, and in this way it is done. If we go about on the voltage level, we have to take care of the face to earth clearance, face to face clearance, and different type of the sectional clearance also, in order in order that the workers who are working, they can safely do the work. And many things are there in this surge arrestor. It is connected to the ground. The grounding is very much important for this equipment, as it is one of the most important protection equipment in our substation. Then other equipment such as current transformer and voltage transformer are there. They both are also one of the most important, the critical uh, equipments of our substation. In current transformer, there are basically five cores. If we go about, if we talk about in the at the 220 kV level, those cores, they firstly step down the value of the current. The value of the current is stepped down because we have to connect it with the relay. Then the relay will sense the fault, and the sensing of that fault, it will give the trip command, it will give the command to the circuit breaker. So that's the basic protection system. Uh, so in CT, we we have to take care of many things. Firstly, many things are calculated. We have to calculate its ISF, and we have to also take care of the what type of metering class we want to use. It can be 0.2, it can be 0.2s. We also talk about the protection class. It can be PS and it can be PX or PX and PS. There are different types of rating calculations, and there is also I've also talked about the knee point voltages. And with CT, there are many relays connected to it. Firstly, there is a bus bar protection relay is there, in which we protect the bus bar. That bus bar protection relay, there is a system. Yes, sir. Hmm. Okay. Hmm. In that bus bar, so there was a there is a laddu. Huh. So in that busbar protection relay, it has there are different types of busbar protections. Firstly, there is high impedance relay. There is low impedance protection, not relay, low impedance protection. And the CT is also connected to the overcurrent relay, earth fault relay, which are mm, specified in the single line diagram with different codings. There is over voltage relay also, there is under voltage relay also, and there is a differential protection relay also. There is mm, distance relay also. So these there are the different types of the current transformer, and and we also use the voltage transformer. Uh, and there are basic different types of mm, input that are required by the relay. So these inputs are provided by the VT and CT in order to have a good protection system in our substation. VT and CT are required at mm, their their relevance is very much because we want them to be in a very good shape. That's my point. Now, another type of equipment which is used, that is called the circuit breaker. The circuit breaker is used for different voltage level. At 220 kV voltage level, we use sulfur hexafluoride circuit breaker. At the 33 kV, we use the VCB vacuum circuit breaker. Then another equipment which is very much used, it is the disconnector and the isolator. So people ask what is the difference between the disconnector and what is the difference between the isolator. And well, there is no difference between them. There's one in the same. It's just a different name. And that disconnect and the isolator, it is the offload device. It is the most important thing is it is used in the maintenance time. We have to isolate the circuit. Then there is also the earth switch with the isolator in order to mitigate the leftover charges. And so there is also different types of calculations regarding the sizing of it, and there is also the different types of the assessments for the isolators. Sometimes there is a requirement of the earth switch. In the line side, we always use the earth switch isolator, which is towards the line, one of the most important thing. And yeah, and the more and other equipment which are used are the transformers. Is the one of the most I think you can say the heart of the substation. It is called the transformer. So transformer, we have to when we see the transformer, we have to check its. We have to select its size, at which voltage level it is. It has to be used. Which type of transformer we have to use. Step up, step down transformer, and we have to also check its vector group selection. We have to check and what is the vector group selection. We have to also check its GA and the GTP, the load losses, the node load losses, and the nameplate. We have to also mark we have to also study the transformer's nameplate. We should know what is the size of the transformer, how much oil it is having. We should also take care of the OLTC. We should also take care of the radiator which the transformers have. Then we also have to take care of the transformer protections. We have to protect the transformer from the internal and the external faults. And for the internal faults, we can say that we have the REF, restricted earth fault relay. We have the SEF, standard earth fault relay. We have the other relays. The Buchholz relay is one of the most important thing for the transformers. And there are different types of transformer which is used in the industry, from right from the 11 kV to 765 kV. Then there is in a substation we also use the cable, we also use the control cable. And when we make the substation, the single line diagram is one of the most important thing which we use in our substation. In the single line diagram, we should be knowing which type of bus bar is required, what type of the bus bar scheme we are having. So right now we are using the double main bus bar scheme in the 420 kV level, 440 kV level, 400 kV level. Sorry, 1.5 circuit breaker scheme is used. And basically there are different type of bus bar scheme. The single bus bar scheme, it is used for the lower voltage level. Then there is main and transfer bus bar scheme. There is double main bus bar scheme which wives tell, and there is double main and transfer, sorry, not transformer, there double main and transfer bus bar scheme. 1.5 breaker bus bar scheme, not circuit breaker, 1.5 breaker bus bar scheme. Then there is also the switching study of how the substation switching device works. The switching studies, it is basically the study of the how the isolator and the circuit breaker, they interfere, they communicate with each other. How firstly the isolator with the CT will give the message to the circuit breaker and it will get closed, and how it is associated with isolator. There are different types of things which is related to it. Yeah. Then different types of busbar conductor are there. So there is also the calculation of it. And so these are the main points in the single line diagram. In the single line diagram, we also show the sequence of the equipments. We also show the relays. We also show all the equipments which we are using. And then we also the most one of the most another important part in the substation, we take how much square cable we should use in the 33 kV side or in the 220 kV side. We should also know about the types of cable which we are using. We should know about the construction of the cable, and which we should also know about the code which we should use. What should be the technical specification, how to select the cable. It is one of the most important thing. There is different calculations regarding to the HT and LT cable sizing calculation. How much minimum cable size that can take the fault can be used. What should be the full load current value? What should be the cable current rating calculation? What is the voltage drop calculation? It should all be known while selecting the cable. How much voltage drop is there? If the cable length becomes more, then the voltage drop becomes more. So our point is the voltage drop should be lesser. uh, in solar, there are if there are many big solar plants, then there is the voltage drop would be very much. So these are the things which we do in the cable sizing and the sizing calculation. There are many things in it also, but I am just covering the basic part of the substation, what the substation is have. Now, one of the most important thing, the how to install the substation, how to bring. We have done the designing, we have known about the equipments, we have known about the cable, but we also want to know about how to install overall site installation, how to do it. So, firstly, there are many very much guidelines are there, that IEC 61936. There are international rules also to be are there, which says how to do the substations, how to install the substation, and we should also be knowing about the general planning of the substation, how should be the orientation of the placement of the substation. Firstly, the land department gives us the land in which we have in which we have to see where we can fit our substation. For different voltage level, different types of area length are there. I will give you a small example. If we are using a 220 kV level substation, then 10 acres of 8 to 10 acres of land is there, can be used. There is a standard Indian guideline which is sharing that at this type of voltage level, this acres of land is required. So this thing is one of the most important thing. And after that, after acquiring the land, we should know the orientation, which side should be 33 kV side and which side should be the transmission level side. We should also we should know that thing. And the and it is for obvious, the GIS substation is it's small in size, and AIS station is larger in size. And firstly, and after selecting the land, we should be knowing the direction and the location of the transmission line. So when preparing the substation, we should be knowing the direction of the line, and where the line